Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding the equation of a parabola when we're given any 3 points through which it passes. So what we need to know for this is that the equation of any parabola can be written as y equals ax squared plus bx plus c. When we're finding the equation of a parabola, we just need to find the values of a, b, and c. We will do that using simultaneous equations. So let's look at this example. Find the equation of a parabola that passes through these points here. Now, if you're given a point like 0, 5, that's really helpful because remember, c is the y-intercept of the parabola. Here I'm telling you the y-intercept is 5, and thus we have c equals 5. So the equation of this parabola is y equals ax squared plus bx plus 5. I still don't know a and b. That's what I need to find. So I know c. What I'm going to do is form one equation from this point, one equation from this point to find a and b. So substituting in the point -1, 10, what that means is I'm going to rub out y and change it to 10, and then I'm going to change these x's to -1. And I'll do something similar here. Here I'll substitute in the point 2, 1. So I will change y to 1, and I'll change all the x's to 2. So now we have two equations and two unknowns a and b. We could solve them using the elimination method, but I'm just going to clear them up and make them easier to work with. So subtracting 5 from both sides here, I get 5 is equal to a minus b. And over here, I'm going to subtract 5 again. I get -4 equals 4a plus 2b. So now I have two equations and two unknowns a and b. So I need one of the variables to have the same coefficient in both equations. So I'm going to multiply this top equation by 2. So we have a -2 here and a 2 here in front of the b. So now I can simply add together the two equations. I get 6 equals 6a. Of course, the b's cancel out when you add these equations. That's why I did it. So I get a equals 1, and therefore I get b is equal to -4. So I'm not done. I need to write the equation. So it's y equals ax squared, 1x squared plus bx plus c, and then I'm done. Let's look at a harder example now. So let's try this question here. Find the equation of the parabola passing through these 3 points. So this one's a little harder than the previous one because I haven't given you the y-intercept. We can't find c straight off. But what we're going to do is we're going to write the equation of any parabola in the form y equals ax squared plus bx plus c. I'm going to substitute each of these points in one by one. Each point gets its own equation. So starting with -1, 11, I substitute y for 11 and x for -1. And then I do similarly for the other 2 points, 1, 5 and 4, 26. So now that I have the three equations, I'm just going to make them a little easier to read. So after writing them like this, hopefully you can see that we can eliminate a and c and leave b pretty clearly if I subtract this second equation from the first equation. So if I do that, I get a minus a is 0, -b minus b just gives me -2b, c minus c is 0, 11 minus 5 equals 6. So I get -2b equals 6, so that of course means that b is just equal to -3. So now I just need to find a and c. So what I'm going to do is substitute b equals -3 into two of the equations. It turns out if I substitute b equals -3 into both of the top equations, they give me the same equation. They will both tell me that a plus c equals 8. So I need to substitute it into this one as well. So a plus c equals 8 is what I get from substituting into either of these equations. Substituting into the bottom equation, I get 16a minus 12 plus c equals 26. So 16a plus c equals 38. So now I can simply subtract the equations again. 16a minus a gives me 15a. 38 minus 8 is 30, so I get a equals 2, which means c equals 6, and thus the equation of this parabola, y equals ax squared plus bx plus c, and then we're done. All right, let's now look at one more example. So this example is going to be harder still because I don't have -1 and 1 as the two x values. I won't be able to eliminate the a's and c's quite so easily, but I'm still going to follow the same process. I know that the equation of any parabola can be written in the form y equals ax squared plus bx plus c, so I'm going to substitute each of the 3 points one by one into these equations again. So substituting in the x and y values, I get these three equations. I'll just write them in an easier way to understand. So remember, our goal here is that we first need to eliminate one of the three variables. So we have two equations and two variables because we know how to solve those simultaneous equations. So it looks like it'll be easiest to get rid of the c's. I can just do that by subtracting equations. So what if I do the first equation minus the second one? That'll eliminate c. And then the third equation minus the second equation will eliminate c. So first equation minus second equation, 4a minus a, -2b minus b, c minus c is 0, 32 minus 17. Now I'm going to do third equation minus second equation. So 25a minus a, 5b minus b, then, of course, c minus c is 0, and 137 minus 17. So, to solve these equations, I need to make one of the variables have the same coefficient. I'll achieve that if I times the top equation by 8, so then this will become a 24a. So timesing that equation by 8, I'm left with this equation here. So now you can see I have two equations with two variables, and because the a's have the same coefficient, I can easily now eliminate the a's. So I'm going to do that by subtracting. So 24a minus 24a is 0, but what I actually get is -28b equals 0. So that means, of course, b equals 0. So if b equals 0, 24a equals 120, a equals 5, and then we can see that c is equal to 12. So we found a, b, and c. The equation of this parabola is y equals ax squared plus bx. There's no x term because b was 0. And then we just add the c on the end. So y equals 5x squared plus 12 is the equation, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.